block A of mass m1 rests on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of the table, and from its other end, another block of mass m2 is suspended. The coefficient of kinetic friction between the block is mu k. When the block A is sliding on the table, the tension in the string is. This is one such question where students often get confused, not because the question is difficult, but because of the fact that there is no diagram given. So let us see how to do that. Let us see how to overcome that. So find out what's given in the in the question. It says the edge of a table, right? So we have edge of a table, and what is present here? A pulley is present here, right? And the frictionless rope or a frictionless string is passing through it. At one end of the string, we have a block of mass m1. At the other end, we have a block of mass. We have a block of mass m2. Okay, and it is given that the block A is sliding on the table, which means the block A is moving like this towards the left, which means m2 would be moving towards the vertically downward direction. It's also given that there is kinetic friction. There is kinetic friction. So say there's friction in this table here, and the coefficient of kinetic friction is given to be mu k. All right, it's a very simple question. Let us first try to understand the question in two different components for block m1 and for block m2. Okay, which will make our understanding even more better. So let us first write down for the block m1. For the block m1. Now for the block m1, what I'll do is I'll draw the diagram one more time. So this is m1. What do we write first? We draw the net direction of motion, which is towards the left. And we know that if there is an object placed on the surface, it will experience a weight. Normal reaction would be acting against the body. Right, sorry, will be acting in the perpendicular direction against the surface of contact. Now, since there's a string connected here, the tension will be acting away from the point of contact on the surface. So this will make it tension, right? And since the net direction of movement is towards the left, we can say that there is friction. There is friction that is acting towards the right. Okay. So there's friction acting towards the right. Okay. In which case, is there any movement for the mass m1? Is there any movement for the mass m1 towards the vertical up direction? No. Is there any movement for the mass m1 towards the vertically downward direction? No. The mass m1 is moving only along the surface. It is sliding along the surface, which means that for this body, sigma fy is equal to 0, and we can say that sigma fx has an acceleration which will be equal to m1 into a. Right? Now, what does it mean sigma fy is equal to 0? See, look at the forces which are acting in the y direction, n and m1g, which means n vertically upwards would be compensating m1g vertically downwards. Sigma fy vertical direction, sigma means sum, so n in the vertically upward direction would be balanced by m1 in the vertically downward direction. So we can write here that n is equal to m1 into g. Now what about sigma fx? See, I'll make this concept one more time very clear to you. This is the net direction of motion, which is towards the left, right? And what's happening here? Tension is acting along the direction of motion, right? So this is F net, and tension is acting along the direction of motion. One more time. This is the direction of motion. And where is friction acting? Friction is acting opposed to it. Now, when both the forces are in the same direction, what we do is we usually consider this to be positive and Fr to be negative. So when we write sigma fx, what we'll do is we'll write it as positive t minus Fr is equal to m1 into a, right? Now what is Fr? Fr we know is mu into n, which is equal to ma. M1A. Now, which mu are you talking about? Is it static or kinematic? Sorry, is it a static or kinetic friction? Since the body is sliding, it definitely means that this friction is kinetic in nature. So it is T minus mu k, T minus mu k into n. What is n? From this equation, we have n is equal to m1g is equal to m1 into a. So this is our first equation. Now, since there are two bodies, definitely there should be another equation as well, right? So let us write down that equation also. So to write down that equation, we'll redraw the figure one more time. So this was the table, right? Pulley. I'm not considering the other diagram now. I'm considering only the body which is which is hanging downwards. The mass of the hanging downward body is m2. We know that it will experience a force m2g acting downwards, right? Definitely there will be tension in the string here. It will originate from this point and it will be against the point of contact. So we have tension T in the string here. This body has no horizontal direction movement, no horizontal direction. It will move only in the vertical direction, which means for this body we can write that sigma fx is equal to m2 into a, whereas sigma fx is equal to 0, whereas sigma fy here would be equal to m2 into a. Now what is sigma fy? Let us go to the concept one more time. So net direction of force is acting downwards because the body is moving downwards. Therefore the net direction is towards vertically down, and tension is acting in the opposite direction. One more time. Net direction of motion is acting downwards, whereas weight is also acting downwards. So since they are acting in the same direction, we'll consider weight to be positive. We'll consider weight to be positive. Since tension is acting against the direction of motion, we'll consider tension to be negative. So when we write sigma fy, how can we write this equation as? We'll write this as plus m2g, right? Plus m2g minus tension is equal to m2a. So we got one more equation. Two bodies, two equations. Let us find out, would it be able to solve for the unknown? Let us see. So what is equation number 1? Equation number 1 is T minus mu k into m1g is equal to m1 into a. And the other equation is, say, minus t plus m2g is equal to m2a. Now what I'll do is I'll subtract equation 2 from 1. So this is 1, this is 2. So I'll subtract, or I'll do 1 minus 2. So what do I get? T minus mu k into m1 into g. Now doing minus, right? Minus within bracket we have minus 2 plus m2 into g is equal to m1 into a minus m2 into a, right? So this will become T minus mu k into m1 into g. Minus into minus is plus, so we have plus T minus m2g is equal to m1a minus m2a, right? Okay. Now now t plus t is 2t. So what we get is 2t minus mu k into m1g minus m2g is equal to m1a minus m2a, right? So at this point, could we find the rest of the answer? No, we can't. Why? Because there is a again left here. Right. So we need to find out the value of a. Okay, so in which case, what we'll do is we will, instead of finding 1 minus 2 here, what we'll do is we'll find we'll find 1 plus 2. So what do we get? What we get is t minus mu k into m1g plus it is, right? So plus into minus is minus t plus m2g is equal to m1a plus m2a. And now what happens? Right, so t minus t is 0 now. So what you get is m2g minus mu k into m1g is equal to a into m1 plus m2. Okay, so what is a from here? A is m2g minus mu k into m1 into g the whole upon m1 plus m2. Let me highlight this for you. So this is the value of A. But are we done with the question? No, no, no. Why? Because we've been asked to find out the tension in the string and not the acceleration. How do we do that? Let us bring equation number 2 here. What is equation number 2? Equation number 2 says that minus 2 plus m2 into g is equal to m2 into a, right? So I can write this minus t. Okay, let us make it plus t. So we can write that m2 into g minus m2 into a is equal to plus t, right? So m2 into g minus a is equal to t, or m2 into g minus a. What is the value of a? We have a here, so we'll bring a here, which will give it as a is m2g, right? A is m2g minus mu k into m1g. So it is minus, right? So we'll keep this entire into bracket. The whole divided by m1 plus m2 into m plus m2. Okay. And this whole is equal to t. Now, what we'll do is we'll keep m2 here. We'll multiply this. So what we get is gm1 plus gm2 minus m2g minus mu k m1g the whole upon m1 plus m2 is equal to t, right? So if you can observe here, gm2 minus gm2 is 0. And next what we have is m2 can be multiplied inside. So what we get is g into m1 into m2 minus mu k into, right, minus mu k into m1 into m2 into g the whole divided by m1 plus m2 is equal to t. Maybe you can take m1 m2 into g common here. So we write m1 m2 into g is common as 1 minus, right? Which will give us as 1 minus what is left? 1 minus, oh wait, there is a minor mistake here, right? Why? Because we are multiplying this minus inside, so this should become positive. So this is positive. 1 plus mu k the whole upon m1 plus m2 is equal to t. So this will be our final answer. Okay, so let us go through the entire problem one more time. So we got the question without the diagram. We first drew the diagram, right? And then what did we do here? We first solved the diagram for m1 alone. m1 net direction towards the left, friction towards the right, tension is along the net direction of motion, so it is positive. Friction is against the net direction of motion, so it is negative. We wrote sigma fx. We know that sigma fy is equal to 0. Then what did we do? Then we came to the second set of diagram where we considered M2 acting downwards, net direction moving downwards, so weight is positive. Tension is against the direction of motion, so tension is negative. We wrote one equation. Then what did we do? We solved these equations simultaneously to obtain the value of acceleration. Then we substituted the value of acceleration back in equation number 2, to find out the value of t, right? So yes, see, these kind of questions become easy for me because I practice this for a longer period of time. So for those people, for those students, I would say who are doing it for the first time, you may find it difficult, and the key to overcome that difficulty is to practice more. Right? The more and more you practice, the better you become at solving problems. So this is one such question where the figure was not given. Well, we have a similar question, not using the pulley rope system, but a very similar question to find out the force and these kind of values. But here, unlike this one, we have a given figure. So here again, the next question we'll draw free body diagram and try to solve these. So do solve this question on your own one time, right? Take some time. Don't copy down the question. Take some time. Try to solve it on your own. Come back to the question. Come back to the solution if you find any difficulty, and clear the difficulty. If you have any doubt, please feel free to ask me. Our students watching it online, please make sure that you feel free to write to us. We'll definitely get back to you. And once you're done solving this question, maybe what you can do is you can go to the next question and try solving it. If not, if you're not confident in this question, please do this. Do solve this question one more time, which will increase your confidence level. Having said that, let's move on to the next question, which is question number 10.